So for this problem, we'll probably want to draw first a nice graph that will help us to know what we're doing. Okay, so we'll first draw an axis. This is a positive one, and this would be this, okay? This would be x, and over here we will have y. Now we'll have to draw the movement of each one of the elements. So the wind, we know, goes from west to east. So this would be more or less like this. This would be the wind. Okay, now we know that we want to fly due north. That means we want to do this over here. This would be the desired thing. So we'll probably have to do something very, very awkward to go from this point to this point. So probably our vector direction of the plane should go more or less like this. Okay, so when we add both vectors, the wind plus the plane, we'll get the desired one. Okay, that's the direction due north that we want. So for that, we can start like doing some stuff. We want to know which direction should the plane head. Okay, so we know that. Let's draw a note on the triangle that if we're gonna go north. Oh, that's a great line. And the wind goes this way. This is a 90. And this for sure is a thing we don't know, but we know that. Let me change color. Nice orange will do. Right, yep, sure. So, and this is the way the plane is going. We can see that this is a triangle, and actually we can note this angle. Okay, so for doing this, we need to do a trigonometry property. Okay, we have the adjacent side and we have the hypotenuse. Okay, so from here we can actually do some funny stuff called arc cosine. Okay, so that would be theta. It's a cos of the adjacent thing over the hypotenuse, and that is an angle of 63.25 degrees. Okay, but that angle is actually this one over here. Okay, we're not interested in this one. We're actually interested in another one. That is actually this one that goes from here to here. So how do we get this angle? We actually need to do a subtraction of 180 minus 63.25, and that is 116.74. Okay, so that's my first answer. Now the second one, how fast does the plane travel relative to the ground? That's an easy one too, because we can use that law from that funny guy named Pythagoras. And well, if you notice, we already have two sides of a triangle, and we need to find the other one. We have the hypotenuse, and we know one of the catetes, so we just need to know the other one. So we know that that would be like 200 squared would be equal to 90 squared plus something squared. I'm gonna call it b squared. Okay, so b squared would be just like 200 squared minus 90 squared, and the square root of all this stuff, that would be b. And if you do the math correctly, we will have 179 kilometers per hour.